So good morning and welcome to this webinar. What we're going to discuss today is about how things are changing in the world of Java. And there are many different things that are changing, not so much in terms of the technology. We'll briefly touch on that, but mostly we're going to talk about how things are changing from the perspective of the delivery of binaries, the way that the Open JDK is developed, the way that support is changing, and all of those types of issues. And then we'll focus on how that's going to impact on how people use Java in their business and what things you might need to decide in terms of how you migrate to newer versions of Java. So what I want to do is to start the presentation with a poll. So I'd like to ask the audience a question, and that's how quickly in the past do you typically move to a new release of Java? And I'll give you 5 possible answers. The first of those is that you deploy into production even before it's released. So you're way ahead of the curve. Then the second one is that you deploy into production as soon as the generally available release comes out. So it's a proper release, tested, verified, and so on. Third option is that you are a little bit more cautious, but you're still looking to use the new one, but you're going to wait for a few months, maybe a couple of updates to come out so that you've got stability built into the system. Fourth option is that you wait right up until the end. So once the public updates finish, then you move to the next release. And the last option, which is a little bit facetious, is, what, you mean there are new versions of Java to use? So I'll give you just a few more seconds to answer the poll. And then once we finish that, we will look at the results. So if we close the poll now, then hopefully we can see the results. There we go. Yeah, and that's interesting because I did this presentation this morning for the European audience, and I got a very similar set of feedback, although I'd have to say that I got slightly more people who said that they used the general available release as soon as it came out. So it seems that for the Americas, most people wait for stability. So they're interested in an overlap, they're interested in waiting to get releases to make sure that any issues are ironed out before they move. And a few people are waiting right up until the end, and then they make the migration once the public updates are released. So what we'll do is we'll go back to the presentation now, and we'll talk about what's changing and how that will impact you. So first of all, let's talk about what we're used to in terms of Java. What has been the way things have happened up until now? Now, the first of those is how the Java platform gets developed. And Java's about 23 years old. It would be 23 years old in May. So we've been through a number of releases. Lots of things have changed. Lots of features been added. The Java platform has really developed over time, become very, very stable, rock solid, and as we know, a great platform to use. But the development of these releases does take time. And if we go back and look at a little bit of history there, what we find is that the time that it took between JDK 5 being released and then JDK 6 coming out was a little bit over 2 years. So we had to wait 2 years for the next release. If we look at the difference between JDK 6 and JDK 7, there was quite a big gap. It was 4 years and 8 months between 6 and 7. Now, to be fair, there were some other things that kind of got in the way. And I'm not really going to talk about those in detail, but you can think of things like the fact that Sun acquired Oracle. There was a lot of issues around Project Harmony, Apache, the JCP, access to the TCK, and so on, that really delayed things between 6 and 7. So that one's a little bit unusual. If we look at the difference between JDK 7 and JDK 8, we're talking a little bit over 2.5 years. And then if we look at the difference between JDK 8 and JDK 9, that was 3.5 years. And again, there were some issues there in terms of getting things right with modularity, getting Project Jigsaw finished, which held up the release of JDK 9 a bit and delayed it. so that we had to wait quite a long time for JDK 9 from JDK 8. So the next thing to look at is, okay, we've seen that we had to wait a certain amount of time between releases, but then when we got new releases, we had time to migrate our applications. So we had time to continue using the old releases whilst the new releases had come out and were being evaluated, tested, and any of the issues being ironed out. So again, a little bit of history. We look at the difference between JDK 5 and JDK 6. We're actually 2 years and 11 months, nearly 3 years of public updates to JDK 5 after JDK 6 came out. That meant you could continue using JDK 5 quite happily for nearly 3 years without needing to migrate to JDK 6. In the case of moving from JDK 6 to JDK 7, you had over 18 months, over a year and a half of public updates. So there was still a nice long time that you could figure out how to move your application, what needed to be changed, doing all the testing and things like that to make sure that you had the ability to migrate in an orderly way between 6 and 7. If we look at the difference between 7 and 8, then okay, that's come down a bit. We're into the Oracle way of doing things rather than the Sun way of doing things. And we still have over a year of public updates. So it's not like you've only got a couple of weeks, you've only got a couple of months. No, you've got just over a year to test your code, make sure everything works, and then migrate in an orderly way from 7 to 8. The other thing about the fact that we have these significant overlaps between different releases and the public updates is it really does allow for stabilization to occur. So we saw that some people wait for a couple of updates, some people will move straight away to the general availability release. And as those people do make the migration, they will find things that maybe need to change and they will report them back to Oracle. So those things can be ironed out in an orderly way, and more people can then take advantage of that as they make their migration. So there's plenty of time to do that, plenty of time for the platform to become stable. So what are we talking about in terms of the Java platform today? Well, I've used this word many times, stable. We have a stable platform. It's been around for 23 years. It's very well tested. It's been used in many different situations. And so we know that we have a good, stable platform to work on. It's secure. So a lot of work has gone into ensuring that Java is a secure platform. Various issues have been addressed. Certainly a few years ago, there were a number of things that needed to be looked at around the area of the browser plugin. They all got fixed. But we have very regular security patches, very regular security updates in the form of the CPUs, critical patch updates. And the last point is that we have free. So we don't have to pay for Java. We can download it from Oracle, we can download it from Azul, we can make use of these things for free. And we continue to get these public updates for both the current release and, as I've said in the past, we have the updates for the previous release overlapping with the current release. So that's where we're at today. Stable, secure, free. The other thing that we need to talk about is the way that Oracle distribute their binaries. Now, the OpenJDK project is the source code that was released originally by Sun and is now maintained by Oracle. And that is the reference implementation for the Java SE standard. That's the thing that's defined through the Java community process. There are JSRs, there's an expert group, lots of work goes on in that area. Now, OpenJDK includes all of the Java SE standard plus a few other things which are not directly covered in the standard. But Oracle, when it builds its binaries, have things which differ slightly even from the OpenJDK source. If we look at what those things are, well, firstly, there are some additional features. There are things like the browser plugin. There are things like Web Start, so that you have the ability to deploy applications through applets, to have desktop deployments where you can update things automatically over the web. There are some additional tools. The most popular of those are Flight Recorder and Mission Control that give you the ability to determine exactly what's happening in terms of the way your JVM is running, what resources it's using, how many threads, how much memory, all of those types of things. So very useful tools that are used as part of the Oracle JDK. And then what Oracle also do is they replace some of the parts that are open source with some closed source versions. And the primary reason for doing that is because they want to get better performance in certain areas. There are certain things where they think, okay, font rendering engine, color management, the graphics renderer, situations where the open source version is not quite as good in terms of performance as a closed source version, and they will actually make replacement of that. And then the other key thing is that the license that they use for the Oracle JDK binaries is different to the license of the OpenJDK source. OpenJDK source is released under a GPL version 2 license with the class path exception, which means that you can deploy your application onto the JVM, you can distribute it without having to provide the binary source for your application. The Oracle binary code license has some restrictions on it, which dates back to the times of Sun. And the key thing here is what we call the field of use restriction. The JDK can be used completely for free if you're using it in a general purpose environment, general purpose computing environment. So laptop, desktop, server, then completely free to use. If you want to have something which is not a general purpose computer, then you need to license the code from Oracle. That's where we're talking about embedded systems, but even if you have a kiosk, for example, you may embed a complete PC into a kiosk, but because it is a single purpose machine, it has to be licensed and you can't use Java for free. So that's the difference in terms of the Oracle JDK binaries. One of the things that JDK 9 has done is to change the way that you deploy or can deploy the Java runtime. What we used to is you download the JDK from Oracle, you download the JDK from Azul, and you install it on your machine. Then you have different applications that you are running in Java use that central JVM. JLink builds on the work that's been done with modularity in JDK 9. And the idea is that you build a runtime which is specific to your application. And it only contains the modules, that's both the JDK modules and the application modules, that are specific to your application. By doing that, you can then deploy the runtime as part of your application. And this is very well suited to what we've seen recently in terms of the popularity of containers, things like Docker. So you can build a runtime image for the JVM, the JDK, which is suited only to the thing that you want to put in your container, and then you can ship that with your container and deploy it in the way that you want to. Minimizes the space requirements that are required by the runtime. So we look at a very simple example of that. If I want to create a runtime for my application that I've created called Azul app, I can use JLink, I can specify where the JDK modules come from, where my modules come from, which is my main module, and then where I want the output of my runtime to go to. If I go into that output and I run the Java command and I ask it to list the modules, what we'll see is that we've got the base module, java.base, java.logging, java.sql, java.xml, and then we've got some application modules, app, zoop, and zeta. So I haven't had to specify that. The system has figured all that out for me, determined which modules need to go in the runtime, and then provided them for me. JLink has some implications because if you go right back to the beginning of Java, we've had this slogan, which is write once, run anywhere. And that's been around for a long time. Often people refer to this as write once, test everywhere. And it really has held true in a large part. Certainly, you can take an application that's been written in Java, you can compile it using Java-C, and then you can run it on Mac, you can run it on Windows, you can run it on Linux, and you don't have to do any recompilation. It will work quite happily on lots of different machines. JLink generates a runtime which might not include all of the standard Java SE modules, which means that immediately you've got to be thinking to yourself, well, this can't conform to the standard. If I don't have all the libraries there, then we don't have write once, run anywhere, and this is one of the big things about Java. So in terms of the specification for JDK 9, things were changed. And the developers said, okay, if you create a runtime using JLink, then it will still conform to the Java standard. Even if it doesn't include all the Java SE modules, then it can still conform to the Java specification. And the way that it does that, it has to obey effectively two rules. One is it must include the java.base module, and that's the module that everything depends on. So java.base has to be there. The other thing that it has to do is if it includes any other of the JDK modules, then if the modules that it includes have what are called transitive dependencies on other modules, then those modules must also be included. And that's what's defined as a closed implementation. So all the necessary modules are there. If we go back to the example I just showed you, my code had a dependency on using SQL. So it needed the java.sql module. But the java.sql module has a dependency on java.logging and java.xml. So even though my code doesn't depend on them directly, those transitive dependencies mean that in order for the runtime that is generated to conform to the Java specification, it must include java.sql, java.xml, and java.logging. So that's where Java is at the moment. What is changing moving forward? There were a number of announcements that were made a little bit before Java 1. So at the beginning of September last year, Oracle made a number of announcements about changes that they were going to make in terms of the OpenJDK and the JDK binaries. First of these is that the OpenJDK is going to have a new release model. It's going to be time-based rather than feature-based. What this means is that from this year, we are going to have 2 releases of the JDK every year. There will be a release every 6 months. Because JDK 9 came out in September last year, the next release is going to be in March, so it's going to be JDK 10, and then the release after that in September will be JDK 11. So in 2018, we'll have 2 releases of Java, JDK 10, JDK 11. What this means is that Java suddenly becomes more agile. The ability to get new features into the language, new features into the library is going to be much easier. We'll be able to get them much more quickly, and that is a great thing from the point of view of developers. In the past, the target for a long time had been to have a new release every 2 years. And as I explained at the beginning, we never really hit that. I think we got 2 years, 2 months was about the best we managed. But we were continually not matching the idea of 2 years. So people were having to wait a long time for new features. By having a new release every 6 months, things that people want can be developed and can be implemented more quickly, and they can have access to it when they need it. How that works is by changing things around. The way things used to work for major releases was that when a release came out and planning started for the next release, a set of features would be identified and planned for that release. And only when those features were complete would the release be made. And that's why we saw with JDK 9, there are a number of delays because the platform module system wasn't quite ready, it needed some more work, and it delayed the release of JDK 9. What's going to happen from JDK 10 onwards is that it won't be features that drive the release. It will be the time. So in March, a release will come out. Whatever is ready at that point will go into that release. So long as something is feature complete, it can get moved into the deployment tree, and then it can get built and released as part of JDK 10 or JDK 11. So although there's a lot of planning going on about what features might be developed for Java, and there's lots of ideas around that, rather than those being targeted at a specific release, they will be developed separately from the JDK, and when they're ready, they'll be made part of the JDK source tree and delivered in the next release. So it's about time, not features. The next thing that's important is the fact that JDK 9 started cleaning up the JDK. Because JDK is, like I say, 23 years old, a lot of things have been added over time. And that's a great thing because we have many more libraries than we had, we have lots more features, various things have been added in even at the JVM level. But adding things is great, but at some point you have to do some housekeeping. You have to do some cleaning up and removing things which are not really necessary anymore. Going back 20 years, we're in a very different world in terms of development from where we are now. Various things changed in terms of JDK 9. So for the first time, some deprecated APIs were actually removed. We've long had the idea of deprecation. We've deprecated many APIs over the years, but none of them have actually been removed until now. 6 methods, 1 class, gone from JDK 9. A number of redundant features were eliminated. So there's things like the JHAT tool, the JVM tools interface, hprof agent. These are things that were introduced as experimental or demonstration features, but were never really updated. They weren't maintained. So it made sense to remove them. There are also a number of GC options that were removed. They were deprecated in JDK 8. Things like having the parallel new collector with the serial old collector. A lot of these options were related to the incremental concurrent mark sweep, which was removed from JDK 9. And then there was another thing which was introduced, which was unified JVM logging. Now, the key thing here is that by introducing a new unified logging system, a lot of the flags that we're used to using in JDK 8 and earlier for configuring things like GC logs, those have changed. And some of the ones that you were using in JDK 8 will actually prevent the JVM from starting in JDK 9. The key thing about this is that suddenly JDK 9 has introduced changes which are not backwardly compatible. In the past, Sun and then Oracle have been very concerned with making sure that backwards compatibility is the key thing for Java. Now, with JDK 9, the decision was made to start cleaning up. And so it means that there isn't guaranteed backward compatibility. That's going to continue moving forward. So Oracle have said that from now on, there may be breaking changes that will be introduced in newer versions of Java. They want to continue this idea of cleaning up. They want to continue the idea of housekeeping to remove some of the things that are no longer necessary in Java. Now, they've also said they will give you warning. So anything that will be removed is going to be deprecated first. And you will get a minimum of 1 release in warning. So couldn't really get a smaller than that. So you get 1 release as warning, which is potentially only 6 months because of the new time-based release. So things are going to change more quickly, and that also means compatibility things will change more quickly. Some of the things that you need to be aware of that are going to change and will be removed. JDK 9 deprecated some significant features. Key thing here is the idea of applets as deployment mechanism. Not many people are still using that, although there are some people who are. There are certain applications still use applets, but they have been deprecated. The applet API, the applet web browser plugin, WebStart has all been deprecated. So you need to be aware, if you're using these things, that at some point in the not too distant future, it won't be JDK 10, maybe JDK 11, maybe JDK 12, these things will actually be removed. Same goes for the concurrent mark sweep garbage collector. We now have the G1 collector that's been around for quite a while, and Oracle have decided that's a suitable replacement. It's a low pause collector in the same way the CMS is. So a suitable replacement for CMS, and they don't need 2 collectors which are doing roughly the same thing. So that has been deprecated and will be removed at some point in the future. There's also some other smaller things like the Java policy tool, JConsole, Doclet API, various bits and pieces. But the things that are going to be removed is also extending to modules. Now that we've broken up rt.jar into lots and lots of modules, it's easier to select things which might be removed to streamline the JDK itself. One of those is a meta module, which is java.se.ee. And this is a collection of modules which are really related to the enterprise side of Java. And they were introduced over time, and realistically, you know, you could argue that they probably shouldn't have been included. So the idea is now that they are going to be removed. Things like Corba. Again, very few people use Corba. There's things like the transaction support, activation support, and some of the APIs and libraries which are used around web services. And that's specifically web services that use things like SOAP and WSDL, rather than the other ways that we do web services in terms of like RESTful web services. Those will still be there, but the less popular SOAP implementations are going to go away. So these are the things you need to be aware of. Another thing that Oracle said is that they're going to open source more things in the Open JDK. Specifically, Flight Recorder and Mission Control are now going to be open sourced. That's a good idea because it means that people will have access to the source. They'll be able to build it as part of Open JDK. They'll be able to use them without any restrictions which they've had in the past. And part of the idea of this is that having a goal of there being no functional difference between an Oracle binary of the JDK and a binary that you can build straight from the Open JDK source. So the idea is that they will in effect be identical. There won't be any differences between the Oracle binary and the Open JDK binary. That is targeted for completion towards the end of this year, maybe JDK 12, we're not quite sure yet. Again, talking about Oracle binaries. So up until now, the Oracle binaries, as I said, have been released under the binary code license. You have to accept that license through the click-through where you click on the little checkbox to say that you agree to the license, even though, if you're like me, you have no idea what the license actually says. As I also said, that has the classic field of use restriction built into it. What Oracle have said moving forward is that they are going to make binaries available in addition to the Oracle ones under a GPL v2 with class path exception license. Now initially with JDK 9.0 that was just for Linux, and more recently, in fact, I believe this week, we've seen binaries for both Windows and Mac become available under that license as well. The other thing that Oracle said was that they were going to reduce the number of platforms that they provided binaries for. They were going to stop providing binaries for any 32-bit operating systems. Windows, Linux, they were not going to be supported anymore. They also have said that they are not going to, from JDK 9, support the idea of embedded software, so embedded development. So things like ARM, PowerPC, those have all gone as well. The only versions that Oracle would be providing, and that's both the binaries under the GPL license and the Oracle binaries, will be Windows, Linux, Mac, and Solaris Spark, all as 64-bit versions only. Big thing, availability of updates. So we talked about the binaries, we talked about the way things are developed. What about the updates? So shifting to a new time-based release model means we have lots more releases than we had before. And that makes the ability to provide updates a lot harder for Oracle or for people developing using the Open JDK. To simplify that, Oracle have decided to classify JDK releases as one of two things. It's either going to be a feature release or it's going to be a long-term support release. Feature release will only have updates for 6 months from the release of that particular version. Long-term support release will have 3 years of updates from the release of the version. The key thing here, and this really is probably the biggest thing that I need to get across in this whole presentation, is there will be no more overlap of updates. I have put this in bold, I have underlined it so that it will make it very obvious. No more overlap of updates. Again, we talked about the history. I talked about how there was 2 years, 18 months, even just over a year of updates for the previous release parallel with the current release. That will not happen anymore. So when a new feature release comes out, the previous feature release will stop getting public updates. When a long-term support release comes out, the previous long-term support release will stop getting updates. This is very significant. It means that if you are thinking about how to migrate your application from one version to another, then you need to think carefully about planning that and understanding what you need to do in order to make that work. Which ones are feature releases? Which ones are long-term support releases? To simplify things, because JDK 8 has been out for quite a while now, that has been classified as a long-term support release. And although I said that you would get 3 years of updates, because of the way things are actually aligning and the fact that JDK 9 took more than 3 years to come out, you will actually get more than 3 years of updates. But this is just to align JDK 8 and JDK 9 into the new system. JDK 9 is a feature release, which means you will only get updates until JDK 10. JDK 10 will come out in March of this year. Version 9.0.4, the second update to JDK 9, came out this week, and so I know I don't quite understand this, why the second update is called 9.0.4, but anyway, I won't go there. So the second update has come out. There probably won't be any more updates after that. So the next release will be JDK 10. There will be no more updates to JDK 9. The next long-term support release is going to be JDK 11. So that comes out in September of this year. That will start the new alignment with the new update model. That means that public updates of JDK 8 will cease in September of this year. If you're using JDK 8 now, you need to be aware of that, because you will need to be thinking to yourself, what do I do in September? Am I going to move to JDK 11? Am I going to move to JDK 10, 9, whatever? But you need to start thinking about that now. To try and put this into a little bit more context, we've created a picture of this so that you can see the idea that we have all these different releases, so from 7 through to 19. And each of those will have a GPL binary that has availability or updates for 6 months. For the long-term support releases, you will see updates that will go beyond that. But as I say, the important thing is there is this knife edge where when one release comes out, the previous release no longer has any support available for it, no longer any updates. So what does this mean? We talked about how Java is stable, it's secure, it's free. That will continue to be the case moving forward, but there's a big change. The big change is that you must choose 2 of these 3. Let me explain that in a little bit more detail. Right now, you could be using, let's say, JDK 8, and you have a stable release, you have updates, which means it's secure. You can download it from the website, which means it's free. When we get to JDK 11, you have to make a decision. If you want to continue to have security and be doing things for free, then you have to move straight away to JDK 11. JDK 11 will be a brand new release which hasn't been tested in production in people's systems. So you will lose some of the stability you've had before. So you can choose secure and free at the cost of stability. You can choose free and stable, and you can say, okay, I will continue to use JDK 8. I don't need to pay anything for it. I can continue using it. It's a stable release. I can continue doing that. But I won't get any more security patches, so I lose that security feature. I can be free and stable, but not have security. And then you can say, okay, I want stable and secure, which means that if I'm using JDK 8 beyond September of this year, then I will need a commercial support contract. So you lose the free aspect of that. So it's very much about choosing 2 out of 3 moving forwards. It's not like it has been. It's going to be different in the future. Let's talk about what Azul is doing with Zulu and our Java and what we can do to help you with this. So the first thing is, what is Zulu Java? Zulu Java is where we take the open JDK source code and we build it to create binary distributions, same as you get from other people. What we also do is we run the TCK, the testing compatibility kit, and the JCK, which is the Java compatibility kit. Set of tests which verify that the binaries that we build conform to the Java SE specification as defined through the JCP. So that isn't strictly speaking necessary, but it does allow us to guarantee that what you're getting is pure Java. The other thing we do is we've also developed some tools which will analyze all of the source code that we use to build the binaries, and that includes source code that's generated as part of the build process. in order to test all of the open source licensing headers. That way we can verify that everything that we use is pure open source under the correct license and doesn't have any contamination, so there will be no issues, and we'll even indemnify you against that, of having non-open source code in the build that you're using. We've been doing this for a while now, so we have a wide variety of platforms supported. We've got JDK 6, 7, 8, and 9, and we will continue to support the new releases as they come out. The other thing we've done is to decide to have wider platform support. Oracle have decided to reduce the number of platforms they support. We've actually increased. So we have exactly the same. We have Intel 64-bit Windows, we have Linux, we have Mac OS X. We also have 32-bit versions for Windows and Linux. If you're using older hardware, older operating systems, and you still need updates for those older operating systems, then we can provide those to you. We also have focused on the embedded side of things. So we will support ARM 32-bit and PowerPC. And if you're thinking about the future and how ARM processors, ARM v8 processors could be used in the data center, we also have 64-bit version of that as well. We've thought about commercial support, and what we want to do is to provide a very cost-effective way of delivering commercial support for people. Because this is something that is going to become more necessary because of the way that Oracle are changing things, commercial support is something that more people are going to have to think about. What we want to do is to make that so that you can have a very cost-effective commercial support, but still have the ability to migrate between versions in a way that suits you and suits your applications and your data center and your deployment and your IT staff. To do that, we have created 3 different versions of our support. So the first of those is what we call short-term support. And this is effectively what you would be looking at in terms of the feature releases. So rather than having 6 months of support, we will actually extend that by a further 6 months. So you then have 6 months of overlap with the next release. But we'll go a little bit further than that by having 6 months of passive support beyond the 6 months that we give you on top of the normal support. So you have 12 months of updates and then further 6 months where if there's a problem you can actually phone us up and you can get resolution of those issues if you need to. Long-term support. This is again tied into what Oracle are talking about in terms of their long-term support builds, and our goal is to offer longer support than Oracle is offering. What we will do is we will take all of the bug fixes and security fixes which are provided as part of the newer releases, and we will backport them as necessary to older versions. And as I say, we're already doing that for 6, 7, and 8. What we're looking at here is a minimum of 10 years of support, 8 active years plus 2 passive years. So you'll be able to continue using JDK 8 for quite some time to come if that's what you want to do. Then the third thing we're introducing is a different thing, which is what we call medium-term support. And here again, we're looking at providing a way to give overlap between long-term support releases, where if people do want to take some new features which are being introduced between the long-term support releases, they can do that in a controlled way with the ability to migrate smoothly between different releases. So medium-term support, there are going to be 2 of those for each long-term support release. And as you can see from the diagram here, JDK 11 is a long-term support release until JDK 17. So the 2 releases that we will be giving medium-term support for are JDK 13 and JDK 15. The idea is that both of those will have 18 months of support after JDK 17 is released. So in the case of JDK, well, let's talk about JDK 9, that'll have 2.5 years of support plus 1 year of passive, and then when we get to JDK 11, we'll start moving into this model where we'll have 18 months past the end of JDK 11. Again, we've put together a nice picture of all these different releases, and you can see how all these different things fit together. So the idea is that for all of the feature releases, you get a year of updates and a further 6 months of passive support. The medium-term ones, you get potentially 2.5 years or 1.5 years of support plus a further year of passive support. And then for the long term, releases, you get a long time with updates and even further with passive support. So the idea is that you've got a lot of flexibility at a very cost-effective way of doing things, and being able to migrate your applications in the way that makes sense to you rather than having to be dictated to by when new releases come out. So to summarize, basically Java is changing. And I don't mean that from the technical perspective. There's a lot changing in the technical side of things, but there's also a lot changing in the way that Java is developed and the way that it's delivered in terms of binaries and the way that you get support for it. So the first thing is, as I said, faster delivery of new features. 6-month time-based release cadence, all very good for enabling new features to be delivered. We're now going to have 2 types of release, where we'll have a feature release for only 6 months, long-term support release for 3 years. The key thing, as I said before, no overlap of updates. If you want to keep up to date, you're going to have to move between releases far more quickly than you were before. You won't have time to migrate unless you have a support contract. Azul, as I said, can help. What we're trying to do is to provide a very cost-effective way of doing this, so you can extend the support that you need on the releases that you need, ease the migration path for your applications. You're not having to push applications in a direction you don't want to go, and you're doing it at the speed and the pace that you want to use. The other thing that I do want to make a point about is how we can do testing and supporting. And the key thing here is that we're not just taking fixes that we get from OpenJDK and doing the backporting into older versions. If you have an issue with running Java and you have a support contract with Azul, then you can contact us and we will work on resolving that separate from the OpenJDK. We have a large number of engineers, we have global coverage, we have full 24/7/365 coverage, and depending on what level of support you want, we can address these issues in very timely manner. And we have the engineering capabilities so that if you've got problems, we are able to analyze them, we can find the root cause, we can provide a fix for it, as I say, completely outside of the OpenJDK, so we can deliver patches which are completely separate and will address the problems that you may be experiencing. So it's not just about backporting fixes, it's about being able to fix any problems you might identify as well. So with that, I'm going to say thank you very much. This address here will give you more information about what we're doing in the Zulu and Zulu Enterprise space. So if you go to our website, you click on the products section at the top, and you'll find Zulu and Zulu Enterprise. So what I'm going to do now is I'm going to have a look to see whether we've got any questions, and just spend a few minutes. So we've got one question here. So the question is, how will this new support model affect Oracle products like Oracle Forms? That's a good question. And I must admit that's one to address to Oracle. Oracle would need to answer that because I'm not sure how they organize the support around their other products. But I would imagine it will be tied very closely to whatever they want to do in terms of providing commercial support for Java in conjunction with support for Oracle Forms. So I would refer you to Oracle to answer that particular question. Another question is, can you share some obvious differences between JLink and Docker? Well, okay, so JLink and Docker are 2 very different things. Docker is a container where you can deploy a specific application in a contained environment. So it builds on top of Linux, the idea of C groups and so on. What JLink does is enable you to build a Java runtime so that you can tailor it exactly to the requirements of whatever you're going to put in the container. So one of the parts of your container will be the runtime that you built for that application or that module or whatever. So you can deploy that specific runtime with that container and have it all self-contained, so that application is tied to that particular runtime, and it doesn't have to work in conjunction with a Java runtime which is across the whole system. Another question, we have many appliances that are managed by Java applets. Will Zulu on Windows provide support for applets after Oracle ends it? Well, at the moment, I have to say that because applets are not part of the OpenJDK, then Zulu does not include support for applets. So we don't support WebStart, we don't support the browser plugin. We do have the applet API. It is something that we've been looking at. It would depend a lot on the market requirements. So if somebody came to us and said they did want support for that, we would certainly look at it and we would say, okay, can we do that? So it would be something that we could discuss with you to see whether that's something we could actually offer as a thing as part of the support agreement. So we're very flexible about these things. Next question, what are the differences between Zulu and Zing products? Aha, right. So Zulu is built purely from OpenJDK source. So it uses exactly the same internals for the JVM as Hotspot does, so the Oracle binaries. So it has the parallel collector, it has CMS collector, it has G1 collector, it has the C1 and C2 JITs. Zing is where we take the OpenJDK source code and then we replace certain parts of that to provide better performance, different performance characteristics in terms of throughput, in terms of latency. So we replace all of the garbage collectors with a thing called the C4, which is a different collector. More recently, we've replaced the C2 JIT with a thing we call Falcon that's based on LLVM. So they're very different. One is built on open source, one is built on closed source, or partially closed source, I should say. Next question. What do you suggest for library developers who are trying to maximize portability between JDKs? Currently, my library targets JDK 6 as the minimum. Do you expect library developers to start dropping support for older JDKs more quickly than in the past? Probably not, actually. And the reason I say that is because one of the features that was introduced in JDK 9 was multi-release jar files. And so I think what people will start doing is as we move forward into JDK 10, JDK 11, and so on, they will deploy jar files that have the ability to work with different versions of the JDK and be able to pick up different code for those versions. I suspect that in the case where you're talking about there is that JDK 6, there are not that many people using it. So I don't know how many people you're seeing actually using your library with JDK 6, but that has to be a sort of a tailing off number. So you probably will be moving from JDK 6. JDK 7 as well will probably drop off the bottom, and you'll start with JDK 8 and then JDK 9 and so on. So more precisely, for how long will Zulu support applets on Windows? Well, again, as I say, at the moment, we don't have support for applets in the sense of we don't have the browser plugin and we don't have the WebStart technology. If that was something that we decided to go ahead and include into the build, then we would discuss that separately with you in terms of how long you wanted support. Typically, it would be the length of time of the how long we support that version of Java for, because once it's in there, it's relatively easy to leave it there and continue to support it. So again, it's something that we would have to talk to you about in terms of how much of a need there is and what we can do to support that. Next question, can you speak to how JavaFX is going to be included in the OpenJDK, including its features like the JavaFX web view? If OpenJDK is going to be equal to the Oracle binary, is the entire Oracle JavaFX library going to be eventually included in OpenJDK? Okay, so the reality here is that JavaFX is not part of the Java SE standard. So it's kind of like WebStart, it's kind of like mission control in that sense. It's not part of that. It's also a completely separate open source project. So there's OpenJFX. So it's a separate project from the OpenJDK. Now, I'm going to make a prediction, which is not based on anything that I have in terms of factual evidence, but given that Oracle have stated that they want to bring the Oracle binary into alignment functionally with the binaries that they're going to produce under the GPL v2 license for the OpenJDK source code, logically, what that would mean is that JavaFX will no longer be shipped as part of the JDK. So that's what I think will happen. But as I say, I have nothing to actually base that. Nothing has been stated publicly by Oracle at this time that that's what will happen. But if you look at what they've said around migrating to no functional differences between Oracle binaries and OpenJDK binaries, that is what would happen. Next question. I may have missed this if it was in the early slides. What about security fixes? Would they be folded in or delivered on demand? I'm not quite sure what that question means because, as I said, security fixes will be available for the current release, and if it's a feature release, they will be available for 6 months until the next feature release comes out. For long-term support releases, they'll be available for 3 years as part of that. So that's really what they'll be available. They won't be available on demand, they will be available as part of the standard release process. Will you share the slides with the attendees? And the answer is yes. All of these slides will be sent to you, or a link will be sent to you for the slides. We'll also send you a link to the recording of this webinar so you can share it with other people in your organization if you want to. And tomorrow I will try and put these up on SlideShare and I will tweet about it. So if you want to look on my Twitter feed, Speak Java, then you'll be able to find the slides for this on there probably tomorrow. Yes, so I think that's all the questions that we've got there. And I think, given there are no more questions, that I will, one more question. How difficult would it be for Azul to port Zulu JVM to run on the iOS and Android platforms? Yes, that's actually something we have looked at, but again, because we've not seen enough demand for us in the market, it's not something that we have specifically looked at in a big way. If you're interested in that, I would recommend that you look at a company called Gluon, G-L-U-O-N. They have been doing a lot of work in that space specifically. So they do JavaFX, and they also do a JVM that runs on top of Android and iOS as a separate thing so that you can run Java applications across those two platforms. So Gluon is the platform that you want to have a look at for that. As I say, we have looked at it. Theoretically, it's quite possible. When I was working at Oracle, the work had been done, proved technically that it could be done, but it just wasn't deemed a big enough market requirement to actually go ahead with that. Okay, so I'm going to wrap up the webinar there. Thank you all for listening, and that's it. Thank you. Bye-bye.